for ellipses, you can have the ellipse open up and down and left and right, and it changes all the different values. So the first part here is a bunch of details, right? That you need to know what everything is called on an ellipse. So we have these A, B, and C values. So let's draw those out. First, the A values, which will be the long part of the ellipse, always the long part. Okay, it's called the major axis. The whole thing from one end to another is called the major axis. So you would look at half of it, it's called the semi-major axis. So each of these have a value of A. I make this the center right here. This has the value of A as well. So the whole thing is 2A. The whole major axis is, the value is 2A, but each from the center to the endpoints, called the vertices, are just the length of A. So here and here are called the vertices. V-E-R-T-I-C-E-S. There you go. Those are the vertices right here. So a lot of this right now is just what is everything called on an ellipse. So same thing over here. Vertices. Way up here. And way down here. Then we have the shorter length, which is the minor axis. Each of those we call B. So it doesn't matter if it's vertical, horizontal, shorter side's always called B from the center to the endpoints. And then finally, how should I do this? We have one more value. There you go. Hey. So we have these focal points, as you saw in the video, that are somewhere inside. The thing with the ellipses is that the focal points have to be inside. Otherwise, it's not an ellipse anymore. Right? And the distance between the center and the focal point, which is smaller, right, than the distance from the center to the vertice, that's the length of C. So that's what this one is right here. Center to the focal point. And the thing that ties all of these together is if I go back to A, say the length from the center to the vertice, it's actually the same as the length from here to the focal point. Those are actually the same exact value. So this is A as well. Now this makes a, zoom in on here, this makes an interesting relationship. So we have a right triangle, right? So what's the relationship between A, B, and C if this is a right triangle? What would be a very, very good formula here? C squared? What? Plus B squared equals A squared. Very similar to Pythagorean theorem, but not quite the same because the C and the A are switched. C is a leg, now A is a hypotenuse. So that's one of those adjustments you have to make for elliptical orbits and anything that's elliptical, is that slightly different relationship from the Pythagorean theorem. Okay. Pretty cool. Okay. Now, how do you know if it actually opens left, right, or vertically, up and down, right? So it depends on where the A is found, the bigger value, right? So if you look down at the two possible equations, you notice that with the horizontal, the A value, which is always bigger, it's always the bigger one, right? It's underneath the X variable. So that means it's stretching along the horizontal, right? The X. Whereas if the A value is underneath the Y, right? That's how you know it's stretching vertically along the Y-axis. So paying very close attention of which number is bigger on the bottom here will let you know which way it opens, right? Horizontally or vertically. So those are the basics. And there's a few other things about the equations. It's somewhat similar to circles, right? If we just took off this a squared and b squared, it's basically an equation of a circle. However, you'll notice also they're both equal to 1. So no matter what, with an ellipse, it equals 1, whereas circles, it could be any value because it's the radius. So that's one thing that's a little different, and it changes up how we complete the square because we have to have a 1 here no matter what. Okay? So that's the basics, right? So let's look first at two problems that are in the standard form already, just finding the center, finding the focal points, the foci we call them, finding the vertices and graphing it. Do that, and then on the back we'll practice what we did yesterday with what if it's not in standard form and it's in this general form. We'll have to complete the square to put it into this format so you can find all these values. So some of the problems will be a little bit longer. So if it's given to you in this format, you'll have to do all this completing the square work just to get it to look like this, only to go through and find all these other pieces of information and graph it, right? Because we can't really graph anything in this format. We have to switch it to the standard form right here. Okay? But you can see it's kind of a play off of the circles, but we just have these numbers underneath. That's what makes it shorter and longer in certain directions. Okay? So best thing you do is just go through and do these one by one and make sure you do each one carefully. Right? The most common mistakes on these problems, I would say, is just writing sloppy, writing too small, writing too light. I missed a negative. I didn't see it. Writing all your characters too close to each other, so I couldn't see the negative. I missed that part. It's not really the mathematics. It's your handwriting that's going to be the biggest obstacle for a few people. Okay? If you have good handwriting, then you probably will just have to stay organized and you'll be fine. Okay? So first, start off with the center. It's a good place to start. It has the same properties as a circle, right? So just like a circle, we just use these values. They're the h and the k. So, and we're going to graph these as we go along. It does say to sketch the graph at the very end, but it's a little bit easier if you just do it as you go along. So we got 5, 1. So go down there and plot 5, 1. 1, 2, 3, 4, 5, up 1. Okay. There's your center. All right. Is this going to open left or right or up and down, vertically or horizontally? Horizontally, because the bigger number is underneath the x, right, variable, so we know that's going to stretch horizontally. Notice how that's a step you have to take. You don't have to write anything, though. So sometimes people they skip it because there's no writing, and then they might do it correctly and they might not. But you got to check that to see if it's the right one or not. Next, let's look at vertices? Okay, vertices. Okay, good. So, in your answers, you want to write them how I am. You actually want to write out the word vertices. Okay, with a colon. And there's 2 of them, so we want to have both of them. It should look something like this. And the vertices always occur on the major axis. So we determined that we're going to open left and right, so the vertices should be left and right of the center. The question is by how much left and right of the center are they? And that's where you use this value, this a squared value, which is 25. So the a value must be 5. Okay, so we're going to go left 5 and right 5 from the center. So just go over here, your graph, left 5 would be here at 0, 1. And then if you go right 5, it'll be at 10, 1. And we can go ahead and just graph the minor axis as well. It's not on here, but it's to finish the graph, we need that. So minor axis, the smaller of these 2 numbers. Since b squared is 4, b is 2. So we're going to go up and down 2 from the center. We don't need to record these points. It doesn't ask for that. So we're just going to write it in there just so we can have our guiding points to graph the ellipse. So once you get that in there, try to draw a nice oval looking ellipse that connects all 4 points. Try to, there we go, that's better. Nope. Okay, we'll go with that. Alright, next we have our foci. So we have the foci. Write that out, F-O-C-I. So that's also going to be left and right. So the vertices and the foci are always on the same exact line, right? In this case, left and right. So by how much? It's a smaller number than, 5, right? Because 5 is the biggest number of A, B, and C. So that's when you go back up here and use this. If we have A and B, we can solve for C. All right, so let's do that. So we have our C squared plus B squared equals A squared A squared is 25. B squared is 4. So we can just solve for C. So we got now C squared is 21 by subtracting 4 on both sides. And C is going to be equal to the square root of 21. Which, using a calculator, you can find out is approximately 4.6. I'm hearing, yeah, 4.6. So with the vertices, we started at the center and we went left 5 and went right 5. But now we know C value is 4.6, so back to the center, left 4.6 and right 4.6. So one way of writing it is you take the center, right? And we need to go left 4.6, which would be like minus 4.6, and right 4.6. So that's be plus. So whatever we get for C, we just do plus or minus that value. So we could say it's 5 plus or minus root 21. We could write it as a decimal, which would be 4.6. And then we can write it as the actual 2 separate coordinates. Now, it's not necessary that you write it in this format, but it's just another way of doing it, another way of writing it. But for sure, we want to write it this way, where we have 0.4, comma 1, right? And then that's for 5 minus 4.6, that's the 0.4. And then 5 plus 4.6, 9.6, comma 1. Right? So those are the 2 foci. Put those in there, so they're basically right next to the vertices. They're very, very close. So this would have a high eccentricity because those vertices and focal points are so close to one another. And just double check that you answered everything, right? That we went through and yes, found the center, found the vertices. And if you look at the work, it's very, okay, what is the center, right? Says center, colon. That's what it is. What are the vertices? Vertices, colon. That's what they are, right? So be very deliberate in your answers of showing exactly what you mean. This is the answer. Okay? And of course, your sketch, it should include the vertices, the major, the minor, and the focal points that are going to be estimated. Usually this is going to be a decimal of some sorts. It's not going to be a nice, integer. So just be okay with that part. And then show the little work that you might have to do to get the C value here. Okay. All right, go ahead and try that on B and see how that goes. Not too bad, right? Any clarifications needed so far on anything? on this standard form stuff. You will have to graph, so you might have to draw these axes yourself, so just make it as accurate as possible. And check on Desmos as needed. Otherwise, let's move on to the back. And look at the general form so we can write it in the standard form to do all this stuff. Okay, so that's what the back is for. Flip it on over, and how do we complete the square for here? So first of all, how do you recognize that this is an ellipse to begin with? So in the end, you're going to be given a bunch of these general equations and told just to graph them. It's not going to tell you graph the circle, graph the ellipse. You just have to know, how can you tell by looking at this that it is actually an ellipse and not a circle? So you might recall that yesterday there were no numbers here, right? If it just has an x squared and a y squared, like that, that's a circle. Right? Or, less common is that these are the same number. If they're the same number, it's also a circle. But if you have different numbers, right, and it's also addition, then it's going to be an ellipse, right? If there's a subtraction sign here, that's a different graph. If only one of them is squared and not the other, that's going to be a parabola. So there's a lot of little details and clues on how to know which type of graph it is, and it's all based upon these two squared terms. Right? That's how you can decide. All right, so our goal is to start here, get it to look like this so that there's no numbers in front of the completed square, right? And it has to be equal to 1. So those are our goals, and we will have numbers underneath. All right, so let's write it out. Remember how we did this yesterday? It was a much simpler problem. Today has a little bit more work involved. So the first thing we want to do is group the x's together, and then group the y's together, and leave room to complete the square right after them. We also have this number by itself, which we move to the right hand side because it was the radius. We're going to do the same thing here as well. So it's a lot of setup, so spend the time doing this part of writing it out. Remember, after the x term, leave space to complete that square. We got plus 9y squared minus 72y plus more space, and this is going to be equal to negative 144. Negative 144. So a little bit of setup here. So we have an additional step following this, though, that we did not have with the circles. Okay? So in order to complete the square, we got to factor out whatever number is attached to the squared term, the quadratic term, right? So on the x's, I got to factor out a 16, and on the y, I got to factor out a 9. Completing the square works better when we don't have a coefficient here, so we just factor it out, get it out of the way. So you take the 16 away from 16x squared, you're just left with x squared. You take a 16, factor of 16 from 96, right? Or 96 divided by 16, same thing. You get 6. And now it looks like something we can factor. Or, sorry, complete the square. Right? That's what we did with the circle in this format. Don't get too excited. Let's do the y's first. Same idea. Whatever number's in front of the squared term, just factor it out. So we'll have y squared minus 8y plus some completed square number, still equal to negative 144. Oops. All right. Next level. So here's where we want to take it from the trinomial that we're going to complete the square, which will turn it into a perfect square. All right. So I'm going to have an x, write that, And that's when I take the half of whatever the b value is inside the parentheses, which half of 6, of course, is just 3. And then 3 squared is 9. 3 to the second power is 9. And of course, like yesterday, we have to add the same thing to both sides. I added a 9 on this side. I have to add a 9 over here. Well, I didn't quite just add a 9, right? Because there was a 16 in front. So I really added 9 times 16. So not just the 9 from inside the parentheses, but the fact that it's being multiplied by 16s, I got to account for that. So I need to add 9 times 16. And then the 16 definitely comes down, right? It didn't just go away, so we have to leave that there as well. So a little bit same as the circle completing the square, but a little bit more when we got a number in front. And then we repeat the process all over again for the y's. So see if you can do that part on your own. So half of -8 was -4. -4 to the second power is 16. Then I have to add that 16 times the 9 in front. So you see we have a lot of repeated numbers. See the 16, 9, 16, 9. Right, so you're going to see a lot of symmetry from the left and right hand side. And then we have to take a calculator or something and add all that together. That's the new value on the right hand side. In this case it's only, let's see, 9 times 16 is 144, so -144 plus 144 is 0, plus another 144 is just 144. Alright, so we are one step away, and that's it. So our goal is to have this, right, with numbers on the bottom, the a squared, the b squared, and this is supposed to be equal to 1. So how do we go from here to something that looks like this, that's equal to 1? So we need this side to be 1. We could just divide it by itself. Whatever number this is on top, divide it by itself and you will get 1. But of course, just like before, we have to do that to everything. We can't just do it to one part. Divide everything by whatever number is on the right hand side. Now you're never going to divide this bottom number into something in the parentheses. It's always really just going to be this part right here. Those are going to reduce right here, these numbers. So just work to reduce those. The top number should go into the bottom number evenly. Right? If you get 2/3 or 3/4, something's off because in our answer there is no number present in the front, right? So if you're working on these and it's coming out decimals or something, then something might be off. It is possible to have a fraction or decimal a squared and b squared. It's just a little more sloppy, but it's not wrong, but it's not common either. So we go through and we just simplify all this. All right, so this is always going to be untouched. This part's finished. And then you just say, well, how many times does 16 go into 144? And you get 9. Repeat for the y's. So we got y minus 4 squared. How many times does 9 go into 144? 16. A lot of the same numbers, just recycling themselves. And the right-hand side, of course, as by design, we get 1. And here's where you can say, what's the center? Does this open vertically or horizontally? This is vertically because 16 is bigger than 9. 16 is underneath the y, so it's stretched vertically. Right? Then you could find your c values. 16 minus 9. Right? root 7, and all that good stuff, and go through the whole process. Okay, so you can tell that if you're asked to, like, where are the foci of something like this, you have to go through all this, and then use the a squared, b squared to find c squared, and then calculate everything. If you make one mistake here, and it comes out wrong, any calculation of this sort will be wrong as well. So as you're doing these, it's going to be about details and looking at all the small things, making sure you didn't miss something, forget something, not able to read your own handwriting, that kind of stuff. All right, go ahead and try number 1 and see how that goes. Check with one another. So that's going to be it for today. Okay, we're just going to practice this part for today, and then tomorrow we'll look at actually calculating that other number, which is the eccentricity. It's a simple formula, right? C divided by A. So, but let's not rush it. So for your homework, there's going to be some of the problems that say find the vertices, find the foci, find the eccentricity as well. Just do every part of the problem except for that part. Don't skip the whole problem because it says find the eccentricity. Just do everything but that, and then leave room to come back to it later to put in a little bit more work for that last part. Okay, so you want to do as much of this as possible. Okay, some of these for the graphing, these 18 through 22 even, are going to require some more critical thinking. You can attempt those, but tomorrow you'll have time. We'll go over this eccentricity for 10 minutes, and you have the rest of the period to put it all together. So more or less a work day tomorrow. Okay.